Hello, my name is Valeria Ortiz, and I'm going to talk about the acidification of the ocean. First of all, let's talk about the definition, the variable control, and the technical stuff we need to know before we enter to this thing. First of all, the ocean acidification refers to a reduction in the pH of the ocean, and it's caused primarily by the carbon dioxide from the atmosphere. This definition is made by the Ocean Service. The second one we need to know is the limit we're going to use. And the measure we're going to use is called variable control, which means it's called aragonite saturation state. And it's a proposed boundary by Rockstrom in 2009. And it helps maintain the saturation state at 80% of the pre-industrial average level. Then we need to know the technical stuff. First of all, the calcium carbonate it's the chemical compound that forms the shells and the skeletons for many organisms in the ocean. The second one, the pH, which is a measure of acidity and alkalinity, and in the oceans, when the ocean suffers a modification, it decreases the pH, which causes effects in the calcium carbonate. The third one is the increased ocean uptake, and it helps maintain equilibrium, and the ocean absorbs a large percent of this excess in the atmosphere. Then we have the aragonite, that is a form of calcium used by marine organisms like corals to build shells and skeletons. Then, as I was talking about after, state is the reflect of the chemical availability of the carbonate ion. And when it's lower, it means the calcification it gets harder to process it and it gets harder. And last, it's the carbonate ions, which means the essential building blocks for the ocean acidification that to help reduces their concentration. Now that we know all the technical stuff, how does it work? First of all, when the human activity increases the atmospheric CO2, the ocean absorbs a significant amount of this excess of CO2, and it's approximately 25 to 30. And when it's dissolved, the CO2 reacts starting dissolving in water and it creates carbonic acid. When this carbonic acid released in the ocean, it increased the acidity, which means lowering the pH. And these extra ions react with availability carbon ions, which helps reduce their concentration. And this reduction of CO3 directly lowers the aragonite saturation state, which affects the ocean and the marine shells. So now that we know all of this, how this have an impact in the ocean? Well, it makes more difficult for marine organisms to calcificate and to build and maintain their shells and skeletons. The source of information we're going to use for all of this are Rockstorm and Ocean Service and Sheila Hu from What You Need to Know. What is the impact in Mexico and Jalisco? As we know, Mexico has the Caribbean Ocean, and as part of the global ocean system, waters around Mexico are experiencing this decreasing of the Araga trend. The vulnerable ecosystem mentioned in the source I was telling you about, such as coral reefs that are in the Mexican Caribbean, face increasing chemical stress due to acidification. The Mexico data. The Pacific coast. This region is highly vulnerable to the natural coast of whaling, which brings deeper, colder CO2 rich water to the surface. And the global acidification intensified this. The studies show clearly trends of decreasing pH seasonally. When this measure drops below the critical threshold during intense upwelling events. And this has a direct threat to organisms like peptons or important shellfish larvae like abalone, clams, and oyster, and other calcificators vital to the ecosystem. Now, the Gulf of Mexico and in the Caribbean Sea have warmer waters that have generally a higher measure. However, acidification is occurring here too. Evidence show that monitoring show decreasing pH trends while the average might still above 2.75. The reduction is highly significant. The impact is the primary concern is the impact on the coral reef. Example, the Mesoamerican Barrier Reef System. Reduce this measure makes it harder for corals to build skeletons, slow growth, reduce the resilience of the bleaching and diseases, and local factors like pollution can worsen this condition. Link with other planet boundaries. The direct and the strongest one, as you can see, is the climate change because both are driven primarily by anthropogenic CO2 emissions. And mitigating climate change is essential and needs to help mitigate ocean acidification, and the ocean warming adds further stress to marine life. And the second one is the biodiversity loss. As I was telling you, it has direct consequences because it harms a calcifying organism like cocktails, peppers, and everything I was mentioned before. And it helps the ecosystem structure. It affects the structure and the function of the ecosystem like reefs. Example of how do we produce this. The cause is the burning fossils like power generation, transportation, the industry, and the effect is, as I was talking about, reduce the ability of corals to build skeletons and risk of shell dissolutions. Another cause is the land use change, example, the deforestation, with a broad threat to marine calcifier organisms. And now, the bioethical issues that I'm going to talk about. Here are some, but I'm just going to focus on the first two ones. The intergenerational disease justice. Given the long term changes described by Rockstrom, what are our obligation to future generation regarding ocean health? Not only the future generation, but the future generation of marine living species in the world. We have to talk about how does this affect in a long term, because now we're not seeing it, and we're not talking about as much as we're talking about climate change, but it is a problem that it's going to affect future generations in food and in the safety of the oceans, and not only just humans, but it's going to affect the environment that it's all around us. The second one is the global justice and the responsibility. How do we address the global nature of the causes and the impact in ecosystems? So we have to create laws, or we should start with ourselves to talk about how do we help this to reduce these emissions of CO2. Now, the actions to take, first of all, the mitigation. Staying within safe operation requires a drastic reduction of global CO2 emissions. So, there requires to stay away from fossil fuels and transit to sustainable energy. And the second one is the action to take is adaptation and resilience. Reduce other pressure on marine ecosystem. Example, reduce pollution, overexploitation, and this can help build resilience to unavoidable acidification. Then we need to focus on protecting marine ecosystem to better withstand the changing chemistry. The conclusion is the ocean acidification planetary boundary was defined by Rockstrom at 2009 as a critical limit for HR system stability. It is driven by anthropogenic CO2 emissions directly linked to climate change and impacting biodiversity. While the global average hasn't crossed the boundary, we are rapidly approaching it, possessing significant risk. Addressing this boundary involves deep bioethical consideration of justice, responsibility, and the value of nature. The primary and most urgent action we need to know is the deep reduction by the global CO2 emissions. And here are some of the links I use, and that's all. Thank you.